4.2, we're going to talk about triangles. Again, this whole chapter is about triangles, so obviously we're going to talk about triangles. Let's do this. We kind of mentioned this at some point yesterday. I'm just going to grab a triangle here. And we talked about it. Remember I said this is free of charge. You'll learn about this later. Did I say that in this class?
Yeah.
Okay. Remember what you said? And it's something you probably already learned before. You probably already learned about these angles. Like if I called this angle 1, angle 2, and angle 3. Tell me something about these three angles. They're acute, I understand, but what about all together? What do you think, Nico?
Angles together.
That's right. The angles all together. What's that? Don't know. All right. The angles all together add up to be 180 degrees. We mentioned that yesterday. We haven't officially learned it yet, but we're going to officially learn it today. All right. So we already know that, but what I want to do is angle 1 plus, I'll write it down, plus angle 2 plus angle 3 equals 180. That's actually a theorem. If you look, it's the very first theorem of this lesson 4.2. Here's what they call it. Now look, if you look at different geometry books, there are certain theorems that, depending on the author of the geometry book, they may reword it and make it a little bit different and that kind of thing. All right, so this author says this. It's a little bit wordy, but this is what they say. So when you look in the book, you'll see this. So it's called the triangle angle sum theorem. Somebody in the other class, because I taught this, because at my 7th period class, we went a little ahead because we weren't going to meet today, so I wanted to make sure we're on the same page here. So we actually did this yesterday, but somebody suggested they just call it the what did they say? The sum of triangle theorem or something like that, you know? Because what's the sum of the triangles? Or you could call it the sum of the angles of a triangle theorem. I don't know. You know, anyway. But this is probably a good way to say it, I guess. Triangle angle sum theorem. Everybody got that? All right, so that means when you add up all the sides, it adds up to 180. That's a theorem. Now, what did we say earlier about theorems? We can do what with theorems, but we don't do that with postulates. We can prove them, right. We can prove theorems, but we don't prove postulates. So, with that said, let's do an attempt at a proof here. It's not going to be a real formal proof. You do have a nice formal proof on page 244. If you look at page 244, they go through the nice step-by-step. They put every little detail in there. I'm not going to go through that whole thing. What I'm going to do is I'm going to give you a little, like an overview of this proof. All right? And I think it'll make a little bit more sense than just going step-by-step. And what I'm going to do here is this. I'm going to draw another line in here. Now this line is not on this triangle, but I'm going to draw another line, and let's make sure it hits right there. Okay? Now watch what I'm doing. You guys watching? What I'm going to try to do is I'm going to try to prove this. I'm going to try to prove that angle 1 plus angle 2 plus angle 3 equals 180 degrees. And you're thinking, well, how in the world are you even going to get 180 in there? I mean, I don't, you know, again, we have to assume we don't know this. We're trying to prove it, right? So I can't say, oh, I can prove it. You know, all the angles add up to 180. I learned that a long time ago. There's my proof. No, you can't do that. You got to use stuff that you learned earlier in order to prove that this is true. So what I did is I put a line right here. And what I'm going to do is put a couple other angles here. Let's call this angle 4 and let's call this angle 5. All right? Now, I didn't just put any old line. What do you think is true about this line and this side down here? What are they?
Parallel.
They're parallel. Okay, so I drew it so that they would be parallel to each other. Okay, so I'm not making any assumptions about it. I drew it on purpose, parallel to this one right here. I did that for a reason. Okay? Let's do this. Let's take a look at 4, 1, and 5. Do you see something that I could say that I've already learned about 4, 1, and 5? Say it. They're supplementary, okay? Or technically supplementary, I believe, means 2 angles that add up to 180. Well, we have 3 here, but I get the idea, right? They add up to 180 though, don't they? Everybody see that? And why do they do that? It's not really linear pair because, again, pair are 2 angles that add up to 180. But what do they form? If I add up 4, 1, and 5, what do they make? They make a straight line, okay? And how many degrees is a straight line? Or a straight angle? 180 degrees. So, I feel okay with writing this. Angle 4 plus angle 1 plus angle 5. What can I say about those 3 angles? They equal 180. And if I was to give a reason, I'd probably say something like definition of a straight line or something like that, okay? because a straight line is 180 degrees, or straight angle, I'm sorry. Straight angle is 180 degrees. These three angles form a straight angle, so they must all add up to 180 degrees. Make sense? All right, let's keep going. Now, why in the world is this parallel? What does that do for us? Jasmine, do you see what we're going to do with this? Do you see where we're going with this? Have you looked ahead? Rachel, what do you see? You see it. Tell me. What are they? It's alternate interior, right? Okay, so 5 and 3, excuse me, 5 and 3 are alternate interior angles, aren't they? Here's your parallel lines. Here's your transversal. What do we know about alternate interior angles when you have parallel lines? They're going to be equal to each other. So I can write that, can't I? I can say 5 is equal to 3. You're thinking, well, big deal. Well, it is a big deal because watch. Angle 5 equals angle 3. Look at this. Instead of writing angle 5 right here, what do you think we can replace it with? Angle 3. Do you see that? What are we trying to do again? Remember, this is our ultimate goal. Our ultimate goal is to get this to be true. Well, we're getting there, aren't we? Right? There's an angle 1. There's an angle 3. If I could make this what? An angle 2, I'd be good, wouldn't I? All right, can I make it a 2?
Yes.
Yeah, because look, it's same thing. So angle 4. Now, I'm not going to put one arc there because I don't know 4 and 5 are equal, do I? But I can say angle 4 is equal to angle 2. So watch. Angle 4 equals angle 2. So instead of angle 4 right here, I can replace it with what?
2.
An angle 2. What do we call that property?
Substitution.
Substitution. Very good. We talked about that earlier, didn't we? Okay, we've talked about that. And that's something you're going to use quite a bit when we start talking about proofs. This chapter, we kind of introduced proofs in, was it the last chapter I think it was? Yeah. We kind of introduced them kind of at the beginning. This chapter, just to warn you, a little bit later on, we're really going to get into some proofs, okay? And this is like the main chapter out of the whole entire year that we really concentrate on proofs. So I just want to make you aware of it. I don't want to scare you off or anything, but I want to make you aware that we will do some proofs. So let's do this. Let's write this real nice. Instead of angle 4 plus 1 plus 5 equals 180, let's do this. What can we do? Angle what?
2.
2 plus, now angle 1's already in this, isn't it? So I don't have to replace it with anything. I'll just keep it, angle 1. Plus, instead of angle 5, what are we going to replace it with? Or substitute angle 3. That equals what? 180. Now, that basically is this, but let's clean it up, make it look nice and pretty. What are we going to start with? Angle 1 plus what? Angle 2 plus angle 3 equals 180. And there it is. That's basically my proof. All right, if you look at page 244 in the book, they go through it. They get a little bit more detailed on some steps and the reasons why and all that kind of stuff. But basically, we just did it right here. You okay with that? It's not too bad, is it? Now, this is, I don't think this is anything we're going to put on a quiz or a test, but I wanted to just show you why angle 1 plus angle 2 plus angle 3 is equal to 180. So if you're walking down the street someday, somebody taps you on the shoulder and please help me out. I need to know why these angles add up to 180. You'll say, oh, yeah, hold on. Get out a sheet of paper. I'll show you exactly right. You never know. You got to be prepared.
This is what you think about, isn't it? You just wait for
It's
someone
not.
to ask you a question.
I just say stupid things just to get people to
You walk down the street like,
think I'm such a dork. All right. Not that I needed much help to getting people to think I'm a dork, but you know. All right, let's do an example real quick. Let's pause this while I write down the example. Record it. Okay, here we go. Forgot to record, but we started off a little bit. Here we go. We're trying to find angle 7. Angle 7 would be the easiest one to find. In fact, it'd probably be the only one you can find right now. All right, that's the only thing you could find with the information given at first. So it's part of this triangle. Everybody see that? You've got this triangle right here. We just learned that the angles add up to be 180. So this plus this must be 180. Take away 58, take away 65, which I did right there. Anybody doing this? What do you get? Nobody's doing this? 57? Is that what it is? Who's got a calculator? Come on, somebody help me out with this. So angle 7 would be 57. All right, it is. I got the answers in front of me, so it's 57. But I'd like you to punch it in just to see. So angle 7 is 57 degrees. I'll tell you what, make it a little easier for us. I'm just going to get rid of this and put in a 57. Let me just make this red. Okay, so that's 57 degrees. Now, What else is really super easy without any math at all? What do you think? Angle 5. What's angle 5 going to be?
57.
That's going to be 57. Give me a reason. Vertical angles, right? So vertical angles are equal. So that's 57. All right, good deal. Let's see. We could do a couple things here. Angle 4. Okay, let's do angle 4. And so what would we do with angle 4?
Angle 4 plus
Just take...
67.
Let's just do it like this. Instead of setting it up as an algebra problem, we kind of get the idea now. If they all add up to 180, what can we do? We can just take these away from 180, can't we? You see that? So I'm just going to go 180 minus what? 67 minus 57. Is anybody going to do that for me? Thanks for your help. 56 degrees. So angle 4 is 56 degrees. So let's get rid of that. And then that's 56 degrees right there. Okay. What do you think, Chandler? What's next?
Can't you find angle 6 because 57 and angle 6 form a linear pair?
There you go. Perfect. 57 and 6 right here form a linear pair. Or this 57 and 6. Doesn't matter, right? So how do you find angle 6 then? What's the math?
180
Just
minus
180 minus 57. So what's that? 23? 123? Okay. All right. See, I could actually do that one in my head. All right, so, oops, let's turn this back to red. Yeah. This one right here. It was numbered. I just erased it. So that's 123 degrees. All right, we're rolling now, aren't we?
We do angle 9 because it's like.
Angle 9's a right angle?
No, the two together.
Come on, what was my big speech right before we started this? Just because it looks like a right angle doesn't mean it's a right angle. Okay, so we can't assume that.
Since they are the same measure,
Yeah.
can't you like find out what and what equals?
Yeah, exactly. Let's do this. Just to make this a little easier, let's call this x. Is that all right? Just for the algebra's sake. And let's call this x right here. So these two are exactly the same because their little arcs were given. Okay, that was part of the problem. Right, so that's 2x, isn't it? So 2x plus what? 123 equals 180. Do you see that? So this plus this equals 180. So since they're the same, I give them the same variable. Just call it x. So x plus x is 2x plus 123 is 180. So subtract 123 from both sides. And you get what? 57. All right. And then that's 28.5. 28.5. So that means angle 8 is 28.5 and angle 9 is also 28.5. And that covers everything, doesn't it? All right, that's everything. What I want to do, that wasn't hard, was it? Pretty easy. As long as we know that the angles add up to 180, it was kind of cool. Look, once we found one, the rest were pretty easy to figure out, wasn't it? All right. Some were really easy. You just had to do the vertical angles with that one. This one was just a linear pair. So some of the stuff is the same exact things that we've done earlier. All right, so that's going to come back, almost said it's going to come back to haunt us, but hopefully it's not going to haunt us. I mean, hopefully we'll see. All right. So look, I want to show you something. I got a minute and a half, so let me do this real quick. Are you watching? I want you to see the relationship between 123 and this angle right there. Tell me something about this angle and these two.
Correspond.
No, we don't have parallel lines, so we can't go that direction. Look at 56 and 67. Come on. Do some arithmetic in your head. Compare it to 123. What do you think, Kathleen?
56 and 67 added together.
That's right. 56 and 67 add up together to be 123. Do you see that? Watch. Keep that in mind. I got less than a minute. I'm going to show you something after I pause this. All right, here's a situation right here that we had earlier, okay, that we just talked about. This right here is called an exterior angle. I'll just put EXT because it's outside the triangle. So these three inside the triangle would be called what? Interior. Now these two right here are further away from angle 1 than this one is. We call these remote interior angles. What does remote mean? Remote means far, well, kind of far away. You know, you remote control, you can be far away from the TV and still click it. That's why they call it a remote control, because you're further away. So here's what our theorem says, that the exterior angle is equal to the sum of the I'll shorten this, remote interior angles. There you go. We'll do an example here in a second.